What is the difference between an isomer and a resonance structure? Isomers are different compounds with the same molecular formula. Here we have two compounds, dimethyl ether and ethanol. We can see that they're not structured the same, but they do have the same molecular formula. What I mean by that is that it has 2 carbons, 6 hydrogens, and 1 oxygen, but they're placed in different positions. Resonance structures are multiple Lewis structures that describe a single molecule. Lewis structures can be written for many molecules and ions. None of the resonance structures will be the correct representation of the actual molecule. NO3 would be an example of a resonance structure. It has 16 valence electrons. Nitrogen, which is the nuclei, stays in the same position. These characteristics make it a resonance structure. Isomers can be categorized into structural and constitutional isomers. Let's talk about structural. Structural can be categorized into position and chain isomerism. Let's use C3H7Br as an example. In position isomers, the basic carbon skeleton remains unchanged, but important groups are moved around on that skeleton. For example, there are 2 structural isomers with the molecular formula CH3H7Br. In one of them, the bromine atom is on the end of the chain, whereas in the other, it's attached in the middle. If we were to create this model, there is no way that one could twist one molecule to turn it into the other one. You would have to break the bromine off the end and reattach it in the middle. At the same time, you would have to move a hydrogen from the middle to the end. Now let's look at chain isomers. These isomers arise because of the possibility of branching in carbon chains. For example, there are 2 isomers of butane, C4H10. In one atom, the carbon atom lies in a straight chain, whereas in the other chain, it is branched. So butane can be written in a straight chain or in a branched chain, and it will still be the same compound. Functional group isomers. In this variety of structural isomers, the isomers contain different functional groups. That is, they belong to different families of compounds. For example, a molecular formula C3H6O could be either propanol, an aldehyde, or propanone, a cetone. Structural isomers occur when atoms are arranged in a completely different order. C4H10 can be an example. As we can see, here every carbon has a hydrogen attached to it. Some are primario and some are secundario. And in this example, it's still C4H10, but the H's aren't in the same position, and neither are the C's. There are 3 C's in the middle and a hydrogen at the top, but it is still the same compound. Chain isomers and position isomers are also categorized in structural isomers. Geometric isomers occur when there is a restricted rotation somewhere in a molecule. Trans and cis isomers are categorized into geometric isomers. Concluding with trans and cis. Trans in Latin means across, and cis in Latin means on this side. For example, in trans, the H's would be on the opposite side of each other, such as Cl. In cis, the Cl would be on the same side, and so would the H's. In other words, atoms are locked on opposite sides of the double bond. This is known as trans. And in the other, the true conical atoms are locked on the same side of the double bond, and this is known as cis.